Alright, we're being asked to rationalize the denominator. What that means is we're looking for an equivalent expression that doesn't have a radical in the denominator. Okay, so what are we going to do? We want an equivalent expression, so the only thing that we can do to this rational expression is to multiply by a factor of 1, or in other words, multiply the numerator and denominator by the same thing. And what we're going to do is use a special expression that will result in the denominator being a number without a radical. And that is the conjugate of the denominator. The conjugate of the denominator in this case, which is 7 plus square root of 2, is 7 minus the square root of 2. So we'll multiply the top and the bottom by 7 minus the square root of 2. When we do that, now we have to FOIL what's going on in the numerator. So what you see right there in the numerator is the foiling of these two binomial factors. In the denominator we need to do the same thing, except what we're going to do is we'll use a quick way is to use the following property of conjugate multiplication. When you multiply two conjugate pairs, or a conjugate pair together, what you end up with is just the first term squared minus the second term squared. Or in this case, we get 7 squared, which is 49, minus the square root of 2 squared, which is just 2. It's important to note that we could go about foiling the denominator binomials in the same way we did with the numerator. The difference is when you multiply conjugates, these middle terms right here that appeared in the numerator would simply just be canceled out in the denominator, leaving the two end multiplications. Alright, so our final answer is just simplifying the numerator and denominator here. Just to highlight this, our goal was to get this in the denominator, just a number without a radical. That is the idea of rationalizing the denominator. Up in the numerator, what we'll get left with is combining like terms here. The 14 and the 2, or negative 2, give us a 12. And then putting these square root 2 terms together, we get plus 5 square root 2. And there is an equivalent expression with the denominator rationalized.